Okay, here's another example of using the power rule, because you can go the other way around. So let's say we have this, and we have 4 times the natural log of x, and we want to write this as a single log with a leading coefficient of 1. Well, all we have to do is use the power rule. And we're done. So it can go the other way too. Remember, these are definitions, so they go both ways. They're biconditional. Okay, so now let's look at expanding logarithmic expressions. Okay, so if we want to expand logarithmic expressions, then that means we're going to write them out as a product of sum and differences with leading coefficients. We're going to completely expand everything out. So we're going to use all of the rules to do that. So we're going to take a single log and we're going to write it out as a chain of sums and differences with leading coefficients. Okay, so we have log base b So we have log base b of okay, so let's say we have something like this and we want to expand it out. Well, the way we expand it out is, like I said, we want to end with a chain of sums and differences with leading coefficients. Now, there's no exponents in here, so we don't have to worry about the leading coefficients. They're all going to be 1. So we're going to use the quotient rule. So this is going to be log base b of 6x minus log base b of y. And now we're going to use the product rule here, and we're finished. So log base b of 6 plus log base b of x minus log base b of y. And we're finished. So, what about something like this? Log base b of a over c. How would we do that? Well, in this case here, we would just use the definition, right? But you could use the power rule here as well. Now watch what I'm going to do. Again, this is not the way I would do it, but just to show you that there's different ways of getting the same answer. So you could do log base b and write it as a product, right? So this would be a times c to the negative 1, right? I can do that. And then this would be log base b of a, right? Plus log base b of c to the negative 1 power, right? And then I could use the power rule here, and I get log base b of a plus negative 1 times log base b of c. And of course, the negative 1 changes it to a subtraction. And we're done. So we could do it that way too. So let's do another example. Okay, so let's say we have something like this. Now, as long as you follow the rules, you'll get the right answer. It doesn't matter which way you do this, okay? So again, just because I do it this way doesn't mean you have to do it the exact same way. Just follow the rules. So I'm going to use the quotient rule first. So I'm going to write this as ln of x to the fourth y minus ln of 7. And then this is going to be ln of x to the fourth plus ln of y minus ln of 7. And then now I'm going to use the power rule here. I'm going to write this as 4 ln of x plus ln of y minus ln of 7. And I'm done. That's how you do it. Now how about this one? So the log of square root of x. Well, in order to simplify this, I'm going to write it with an exponent. So log of x to the 1/2. And so now I'm going to use the power rule and bring the power out in front as a coefficient. And I'm going to get 1/2 log of x. Okay. Now what about this one? Okay, so now I'm taking the natural log of the cube root of x squared. Well now, again, I'm just going to write this as an exponent, right? So I can write this as x to the 2/3, right? That's what I would do. So I'm going to write it as natural log of x to the 2/3 power. And so then this is going to equal 2/3 times the natural log of x. And I'm done. It's that easy. Okay, see you next time. We'll do some more examples.